let's talk about the derivative today, but we don't just want to talk about finding the derivative. We want to understand what in the world the derivative means. And it's important to understand that because um, math is really the foundation of it really, really kind of explains a lot of how things work in this world. It's amazing when you think about it. And the derivative is one of those aspects of things that helps to illustrate various type of things that happen in the world. And now we're not going to go that deep, but we're just going to understand what the derivative means because there's an actual meaning. It's not just math that you get a grade for. Okay. So let's say if you have a function, a function is denoted as f of x. The derivative of that function, f prime of x, we understand that to be essentially the slope of f of x at any point x f of x. So in other words, if you take the derivative of a function, then and you plug in any x value, it tells you the slope of the function at that particular value. So we understand that. That's kind of like some of the basics of it. So now, let's go a little bit further with that. The derivative, if it tells us the slope of the original function at any x value, then it's basically telling us, if you recall, the slope of a function. I'm just going to do this real quick and just for the purpose of illustration. So if you have a function that looks like this, the derivative being the slope is going to tell you essentially what the slope is at any point. The slope is essentially how a line is pitched, going up or down and whatnot. So obviously here the slope is negative because it's kind of going down. The slope here coming up is positive. Over here, the slope is going negative again because the function is actually decreasing. Okay. So that's all the slope is. So if we want to, let me reiterate what I just said. Basically, the derivative of a function tells you if a slope is if a function is increasing or decreasing. So let me give you a couple of rules here, and just make sure that you're like really visualizing this. So we're going to do a good visual exercise here at the end of this. All right, so if the derivative f prime of x is greater than 0, so in other words, if the derivative is greater than 0, that means that you have a positive slope. That means that the function is increasing. If you think about it, the function is increasing. Okay, so again, you think about this function here, whenever the derivative is greater than 0, in other words, the slope of the line is greater than 0, that's going to be where the slope is going up. That is where your function is increasing, right? See, that's the black line is the original function f of x. Okay, and so the function is increasing along this point here, okay, because the slope is a positive slope. Now, the converse is true, that if f prime of x is less than 0, the function is decreasing. So you see here, the function is a negative slope, like this says. I mean not the function, but the slope is negative because it's going down, just like it says here. F prime of x is less than 0, and the function, as you see, the black line is decreasing at that point. So it's literally showing you, if you can kind of like use your visualization muscles a bit, you see that the derivative can be noticed based on whatever kind of behavior the function has, if you look at it graphically. Now, what I want to ask you is, what happens if the derivative f prime of x is equal to 0? Let's think about that. Now, if the derivative, we're talking about the derivative here, if the derivative is equal to 0, remember the derivative has to do with the slope. Think about this. If the slope is positive, for example, it's going up. If the slope is negative, the function is going down. If the slope is 0, literally it's only going to be 0 in between whenever the slope is positive and negative, or a negative and positive. So what's happening there? Positive slope, 0, negative slope, or negative slope, then slope is 0, then positive slope. That means that the original function has to be a minimum or a maximum. Okay. All right, so let's see. Let's extend this whole conversation a bit. Like I said, we have to be at a maximum or a minimum of the original function if the slope is 0. Because again, if the slope is positive, that means that the graph is going up. Slope is negative, the graph is going down. So that means when the slope is 0, that's going to be between positive and negative. So if you can visualize the derivative now, slope is, if the slope or the derivative is positive, that means that the slope is above the x-axis. If the slope is negative, that means it's below the x-axis. If the slope is 0, that means that is where the derivative crosses the x-axis when it's going from positive to negative, or negative to positive, however you want to say it. Okay. Now let's actually do some more visualization here to make this all really make sense. Calculus is a very, very it's a very kind of like visual kind of math where you really have to kind of see it for it to make sense. Otherwise, if you just kind of like reduce it just to like a whole lot of numbers and stuff, then it's not going to really make a lot of sense. So we're going to draw a couple of XY graphs here. Okay. Not going to be perfect, but make it do whatever it's going to do. So this one is going to have f of x. This is going to be f prime of x. All right. So let's say, choose a different color here. Let's say that f of x, the original function, look something like this. Okay. And what that would, let's think about that. So check it out. You have a situation here where what's going on, this is the original function. The slope is going up, up, up. Well, the graph is going up, which means that we have a positive slope. And then we get to this point. This is supposed to be the top. We get to this point, and then it starts to go down. Again, my drawing isn't perfect, but you get the idea. Oh, pardon me. So and then it starts to go down at this point, and then the slope is at this point negative. Okay, so positive, 0 briefly, and then negative. So let's graph the derivative. So literally, if the derivative, the graph of the derivative is positive, remember that means that it's going to be above the above the x-axis. It's going to be positive up here. It's going to be negative below the x-axis, right? So, and then in between, like right at this point somewhere, at the at x is equal to 0, it transitions from positive to negative, which means that we have in this case, a maximum, we have a point where the derivative is equal to 0. So literally the derivative of this is positive. Then at x is equal to 0, it touches the x-axis. That means it's equal to 0. Then it goes negative. So the derivative of the original function will look something like that. Okay. Now, if we were dealing with a situation where this original function was like a upward facing parabola, then this would be opposite, because like literally you would have a negative slope, then 0, then positive slope. So that means you would start down here with your derivative graph, negative, negative, 0, positive, positive, and so on and so forth. You see what I'm saying? So it obviously gets a bit more complex than that, but that really is like the fundamentals of how to visualize what the derivative of a function actually means. Okay. So, you know, watch this a couple times, however many times you need to understand what's being talked about here, because this is a very fundamental thing. This is really one of the main things that makes calculus what it is, the derivative, and specifically visualizing the derivative. And the more that you kind of practice visualizing it, the easier it becomes. All right, y'all. Hopefully this helps.